All right, today we have a chemical equation that we need to predict the product for. So let's first of all identify which part is our reactant and which part is our product. So this is our reactant, and this with the question mark is our product. So we have our reactants and then we have our products. Okay, cool. So here we have sodium, which is Na. You can look at your periodic table to refer to the different atomic symbols. So sodium is Na. So I'm going to just write sodium, which is reacting with H2O is water. The more accurate or scientific name is dihydrogen monoxide, right? Because it is a covalent bond, so it's going to use the prefix system to figure out how much of the atoms you have. Okay, anyways, you have sodium and water, and they combine to form something. So now the first step is going to be to identify what type of reaction this is. Okay, what is the reaction? The reaction is going to be a single replacement or displacement. How do I know this? Well, let's think about the general form of a single replacement. The general form or structure of a single replacement is A plus BC, which is turned into, okay, now this is turned into AC plus B. Now, the reason why we need to identify the reaction first is that way we can kind of switch the chemical compounds based off of the reactants, the product that we're given in the general form or the general structure of the reaction. So this is the general structure of a single replacement. Now I know this chemical equation is going to be a single replacement or displacement, whatever you want to call it. I just say replacement. Now I know it's going to be single replacement reaction because of its reactant. The reactant side, this is why we identified the reactant and product side. So you can see everything is building on to one another. But anyways, the reason why we identified the reactant side is so that we actually have a clue as to what general structure we are working with here. Now, if you look at our reactant, it is going to be, so I'm going to say R for reactant, and that is Na, sodium, plus H2O. Now, if we look at this reactant, it looks oddly familiar to the single displacement reaction because you have A, which is being represented by your single element here, right? Plus B, C, these are bonded together. They're bonded together. Exactly how hydrogen and oxygen are bonded together. So this would be your B and this would be your C. So if you were kind of confused on the general form or structure of the single replacement reaction, A, B, and C, all of these just refer to an unknown chemical. They refer to an unknown chemical. Okay? So it's just an unknown chemical. Okay, so now that we understand that this is exactly how the single replacement reaction looks, because based off of the reactant, this is our reactant side, this is our product side, you can see that the reactant is exactly how this chemical reaction looks. Let's go ahead and use the product, right, which we see here, and change these variables. So we've assigned the variables of A, B, and C exactly how we want to see it in the actual reaction, right? The alone chemical or the alone element is going to be A, and then the bonded ones, the cation is going to be B, and then the anion is going to be C. Or, sorry, it's just going to be B and C. Sorry, forget what I said. It's just going to be B and C. So for the element that is the first, it's going to be B, and then the second element is going to be C. Because this is a covalent bond, so I realized I can't talk about cations and anions. Just forget about that. Just know that the element that's by itself is going to be A, and then the element that the two elements that are bonded together in a compound, first element is going to be B, second element is going to be C. Let's go ahead and work on the product now. So for the product, it's going to be AC plus B. So we've already assigned the variables. I explained what they are. So how would we do this? Well, B is hydrogen. So let's put H2 here, right? Because hydrogen is a diatomic molecule. And then A is nitrogen, and then C is oxygen. And like that, because remember, we have to put a 2 here because remember, sodium has a positive 1 charge and oxygen has a negative 2 charge. So you do the crisscross, oxygen has 1 quantity and sodium has a 2 quantity. This should be correct, right? Let's think here. What do you think? Would this answer be correct as the product? Is this the product for this reaction? If you said yes, you would be absolutely wrong. This is the wrong answer. This is completely incorrect, and I'm going to explain why in a second. So if we look back into our reactants side, which is this little equation here, you'll notice that the hydrogen is shown as 2. This actually means that you can write H2O as HOH, right? Because there's 2 hydrogens and they're going to be separated into two different compounds over here. And then you have your oxygen like that. So basically, the other way to write H2O is this over here. You could write it like this as well. It's the same thing. Now, the reason why I wrote it this way is to show you that when we're doing the single replacement reaction, what we're essentially doing, I'll write it over here. What we're essentially doing is we're switching the element that's by itself with the first element in the compound. We're switching them, we're swapping them. So then this element will go bye-bye and it'll be by itself. But the issue here is that H2 means 2 hydrogens, right? It means that there's going to be 1 hydrogen atom and then another hydrogen atom. But in a single replacement reaction, one element swaps with another. So it's one element, one singular element that swaps with another element. This means that this product that we wrote is completely incorrect. Why? Well, let's look here. We have our sodium, right? The sodium takes the place of one of the hydrogen. We have 2, right? It takes the place of one of the hydrogens. So let's say it takes the place of this. So this goes bye-bye, it's by itself, and it's over here. Now, since hydrogen is a diatomic molecule, it's going to have 2 because it has to be bonded with another element, right? When it's by itself. So even though, we took out 1, it will show as 2 hydrogen elements because of the fact that it's a diatomic molecule. But now we still have this 1 remaining. You see, we still have this 1 hydrogen remaining. So we didn't account for this remaining hydrogen within this product. Because you can see here, where's that extra hydrogen? Because this hydrogen, H2, is actually just referring to 1 hydrogen. But since that hydrogen can't be by itself, right, because it's a diatomic molecule, you bond it with another hydrogen. But that extra hydrogen from H2 is still by itself. It's still there, but it's not being accounted for in our product. So what do we do with that hydrogen? Well, that hydrogen will now take the form of a polyatomic ion called hydroxide. And the reason for that, again, this is all connected to one another. The reason why it becomes hydroxide is because of this notation here. In this notation, you can see that we got rid of this hydrogen. This hydrogen gets kicked out by the nitrogen. So the nitrogen kicks it out, right? And then the hydrogen gets another hydrogen so that it can actually exist by itself, because remember, it's a diatomic molecule. But anyways, all we need to know is that this hydrogen is gone. So nitrogen takes its place. But what is remaining? What is still there? Well, what is still there is the O and H. So we have to bring that down. So that's going to be O and H like that. And that is hydroxide. This way, we are actually accounting for, first of all, the oxygen, right? We account for that over here too, though. We accounted it in our wrong answer. Our wrong answer, we still accounted for it. But we haven't accounted for that extra hydrogen because H2O means 2 hydrogens and then 1 oxygen, right? So we haven't accounted for that extra hydrogen in here, but in this case, with Na or sodium hydroxide, we're accounting for that extra hydrogen because in a hydroxide, it's composed of 1 oxygen and 1 hydrogen. And then the other hydrogen is being accounted for with the connotation of B, right? B is the other hydrogen, but it has to take the form of 2 hydrogens because it's a diatomic molecule. So that's why it confuses people, because they're like, oh, the 2 hydrogens are already being accounted for in B, right? Because you're writing H2. That means 2 hydrogens, right? Well, not really, because hydrogen is a diatomic molecule, meaning that it must be connected with another hydrogen, which is going to be found from an outside or external source, right? So, in conclusion, our final answer should be Na, or sodium, plus water, which is going to become sodium hydroxide plus hydrogen gas. And the reason for this is, again, we have to account for both hydrogen atoms. This too comes from the fact, this 2 hydrogens come from the fact that hydrogen is a diatomic molecule. Not from the actual H2O equation, okay? So essentially what's happening here, again, if I can recap, is that the sodium is getting rid of only 1 of the hydrogens. So it's taking the place of 1 of the hydrogen, not both of the hydrogen, only 1. Because in a single replacement reaction, you can only have 1 element which swaps with another element. So it takes the place of 1 hydrogen. So what is left in that water now? Well, it takes rid of 1. So if we use a connotation of HOH, right? Just to make it more easier on ourselves, because then we've separated those 2 hydrogens into separate entities, so it makes it much easier for us. So if we look here, the sodium would replace only 1 of the hydrogen. So it replaced this one because it's the closest. So it gets rid of that and it takes the place of that. This hydrogen gets booted out. It's by itself now. And since it's by itself, it cannot be 1. It can't be by itself. It has to be bonded with another hydrogen because it's a diatomic molecule. That's why it takes the form of H2 or hydrogen gas, because this element is mostly seen in a gaseous form. So then this hydrogen is being taken care of, right? It's out. So then this sodium, not nitrogen, this sodium will take the form of sodium hydroxide to account for the 2 atoms still remaining. These 2 atoms remain, right? So that's why in this example of sodium and water, it becomes sodium hydroxide plus hydrogen gas, because of the fact that H2O really is just a hydrogen and then a hydroxide, right? And in a single replacement reaction, you only get rid of 1 single element, not 2, which is what we were thinking of when we came up with our wrong answer. Okay? And by the way, I keep saying this hydroxide, and you might be a little confused on that. Well, hydroxide is just referring to this compound, and the reason why it's called hydroxide is because it's a polyatomic ion. You might want to get a little refresher if you don't understand what that is, and